Alright, welcome back. This is lecture 13 in this course on mathematical tools. The topic of this lecture is trigonometric identities. So, before this, in the previous two lectures, I have introduced the sine function and the cosine function. These are two important trigonometric functions, and we have discussed the properties of these functions as well. Right. So, these functions are actually periodic. What does that mean? That as the value of angle in radians changes on the x axis, the value of the function repeats itself after certain interval. So, in fact, the whole entire behavior of the function starts repeating itself. So, these are periodic functions. Now, after what period they repeat, that will vary from function to function, but these are called periodic functions. Okay. So, and the other properties that we saw, that these functions can be used to figure out um, let's say one of the sides in a right angle triangle given the angle and the hypotenuse, right. Also, we saw that the domain of these functions is, it can take any real value in radians, and the codomain is strictly from -1 to 1. Okay. So, these are some of the properties that we have discussed about sine and cosine functions, and we saw how these functions are actually behaving. It's like if you take a clock and one of the, let's say, the minute hand in the clock is rotating in, let's say, anti-clockwise direction, then as the angle changes, the height of the rotating end of the clock, rotating end of the hand increases with respect to some reference horizontal plane, increases or decreases, right. So, the height of that rotating end with respect to ground is given by a trigonometric function. Basically, it is a function of the length of the length of that rotating end, rotating hand, and the angle it makes with the horizontal reference, right? And that function is actually a trigonometric function. Okay? So, just to recap, let me draw the graph of the sine and cosine function. So, this was the sine function. So, let's say the x axis represents the angle theta, y axis represents the function sine theta, right. So, this is how the graph looks like. At 0, the value is 0. At pi by 2, function takes maximum value. Let's say here you have pi by 2, you have pi here, 3 pi by 2 here, and 2 pi here. Similarly, in this direction, minus pi by 2, minus pi, minus 3 pi by 2, minus 2 pi. This is how the function behaves. It starts increasing rapidly and then they becomes almost constant. At pi by 2, it starts decreasing, and then it decreases, comes to pi, and then decreases even further. Now it would start increasing from here and would go like this, and then it starts increasing like this again. Okay. Similarly, in this direction, it goes like this. Okay. So, this is the graph of sine function, sine theta. Similarly, the graph of cosine theta would look something like this. It actually is maximum at 0 and then it decreases at pi by 2 and then goes like this. Okay. So, this is graph of cosine theta. Okay. Now, there are other trigonometric functions apart from sine theta and cosine theta, which I will discuss briefly, and after that we will take a look at trigonometric identities. Okay. So, another important trigonometric function is actually tan theta. So, tan theta is sine theta divided by cos theta. Okay. And in a right angle triangle, this is how you can visualize this angle tan theta, this function tan theta. So let's say this is r, this is x, sorry, this is r, this is x, and this is y. Okay, and let's say this is the angle theta, this is the right angle triangle. Now sine theta is y by r. What is cos theta? Cos theta is actually x by r. Tan theta is actually sine theta divided by cos theta. That means it would be y by x because r will cancel out. So tan theta in a right angle triangle is perpendicular divided by base. Okay, that's tan theta. So how this function would behave? Well, let us see, let us think about it. So let us take some values of theta and let us take corresponding values of sine theta, cos theta, and let's see how tan theta would look like. This is sine theta, this is cos theta, and tan theta. Okay. So let's say the value of the angle is 0. What is sine theta at 0? 0. What is cos theta at 0? 1. What would be then tan theta at 0? 0 divided by 1. So it would be 0. Now let's say the angle is let's say pi by 6. This is actually 30 degrees. Okay. So at pi by 6, sine theta would be actually I guess 1 by 2. Cos theta would be I think root 3 by 2. So that means tan theta would be 1 by root 3. At pi by 4, sine theta would be 1 by root 2. Cos theta is also 1 by root 2. These two, sine theta and cos theta, are exactly same at pi by 4, which is actually 45 degrees. So tan theta would be 1 by root 2 by 1 by root 2, 1. So tan theta has maximum value, not maximum value, but a value 1 at pi by 4. Let's see what happens at pi by 3. At pi by 3, sine theta is root 3 by 2. This is 1 by 2. So as a result, tan theta is root 3. So this is actually greater than 1. So one thing you can notice is there that the value of tan theta is increasing continuously. Okay, and 1 is not the maximum value. Okay, it increases beyond 1, which is unlike sine theta and cos theta. So let's see what happens at pi by 2, which is 90 degree. So at 90 degree, sine theta is 0, cos theta is 1. Okay, so what would be tan theta? Sorry, I written it wrong. Pi by 2 should be sine theta should be 1, cos theta would be 0. So what would be tan theta? Well, 1 by 0. Okay, now this is undefined. Okay, so let me write infinity for now. Okay, it is undefined at pi by 2. It would have basically very large positive value. Okay, basically it is from pi by 3 to pi by 2, from 60 degree, between 60 degree and 90 degree. Tan theta is actually increasing rapidly. You see here it was 1.73, now it is suddenly infinity, right? So it is increasing rapidly between this and this, right? Let's see what would happen at so okay, this is pi by 2. What if you take 120 degrees, or yeah, let's say 3 pi by 2. What would be the case at 3 pi by 2, which is pi, or not 3 pi by 2, let's say pi by 2 plus pi by 4. Okay, let's say at some value like this. Now at this, sine theta pi by 2 plus pi by 4, what it would be? So this is the sine function, pi by 2 plus pi by 4. So pi by 4 would be somewhere here. So this value is actually same as pi by 4. So it is repeating its value. So it would be 1 by root 2 for sine theta. What it would be for cos theta? Now cos theta at this point is actually going in negative direction. Okay, so it would be minus 1 by root 2. As a result, the tan theta would be minus 1. And what about pi? What would happen at pi? At pi, sine theta is 0. Cos theta is minus 1. but anyway tan theta would become 0. Okay. And if you are close to 90-degree, right, this would be very large negative value. Okay, you can try this. So let's say, let me try a value at pi by 2 plus, let's say, pi by 6, which is 120-degree. So what would be sine theta at 120-degree? At 120-degree, sine theta is a very large value. Okay, so it would be same as what value it has at 60-degree. Okay, so that is root 3 by 2. So sine theta is root 3 by 2. What is the value of cos theta at 120-degree? So here, so it would be minus 1 by 2. So this value is minus root 3. So at 120-degree, the value of tan theta is minus root 3. So it is increasing in the negative direction as you go from pi to pi by 2. Okay. So the graph seems to be growing like this. So we are drawing the graph of tan theta. Okay. So this is the y axis. Let's say this is pi by 2 and this is pi. I'm drawing this line because the function is undefined at pi by 2. The function is although defined at pi, but it would be undefined at then 3 pi by 2. Okay. So from what we have seen, the graph would look something like this. It has a value, so it starts at 0 and it starts increasing almost linearly, but then it suddenly grows near pi by 2. So the graph looks something like this. Okay, here in this quadrant, it was actually very large negative value near pi by 2, something like this, but it would have a value 0 at pi, and it would also again start, it will keep increasing until it reaches, it goes towards infinity near 3 pi by 2. Okay, so like this. So you can extend it in this direction as well. So this, it will become asymptote at minus pi by 2 as well. Okay, so it will behave like this. Okay, so this is minus pi by 2. Similarly, let's say this is minus pi and this is minus 3 pi by 2. Okay, so it behaves in a similar way near 3 pi by 2. Okay. This is how the graph looks like. And this will keep on repeating. So this is how the function is periodic. Okay, this way. So this is the tan theta function. Okay, we also call it tangent function. So this is how it looks like. Now, what is the domain and codomain? Well, domain, it can take any real value except pi by 2, 3 pi by 2, minus pi by 2, minus 3 pi by 2, and so on. And what is the codomain? Well, it can take any negative positive value, right? So the codomain is the set of real numbers. Okay. So this is how the tan theta function behaves. So this is the third trigonometric function, and we have learned that tan theta is basically sine theta divided by cos theta. Now there are some other trigonometric functions which are like complement to these functions. So one of them is sec theta. Sec theta is actually 1 divided by cos theta, basically inverse of this, not inverse, but basically 1 divided by cos theta. And cosec theta. Now cosec theta is actually 1 divided by sine theta. And then you have cot theta. Cot theta is actually 1 divided by tan theta. So these are other trigonometric functions. So this completes all the trigonometric functions that we use, okay, most commonly. Okay. Now I will talk about some trigonometric identities. Okay. One of the identity you have already seen, which was sine square theta plus cos square theta is equals to 1. So this is something I've already seen, and we also discussed the proof why it is sine square theta plus cos square theta is equal to 1, if you remember, because sine square theta is actually in a right angle triangle. Okay, this is y, this is x, this is r. So sine square theta would be x by r square, cos square theta would be y by r square, which gives you x square plus y square divided by r square, and according to Pythagoras theorem this would be equal to r square. So this gives you 1. Okay, and that's why. But there are other important identities. Okay, another one is, some of these also come from the properties of these periodic functions. Okay, so one of the property is this, that sine theta is equals to cos theta cos of theta minus pi by 2. Okay, sine theta is equals to cos of theta minus pi by 2. Then cos theta is actually equal to sine theta plus pi by 2. Okay, so after every pi by 2 interval, sine theta behaves like cos theta. So it would, the value it takes is the value of the function cos theta. Now what if I give sine minus theta? Okay, now this would be equal to minus sine theta, and this kind of function is actually called an odd function, where you have something like function of minus x is equals to minus of fx. If that property holds, then it is called an odd function. Now cos theta is actually an even function. Okay, so if you take cos minus theta, it would give you back cos theta, and we know why this happens, because in the graph of cos, okay, in the graph of cos, it is symmetric around y-axis, right? So whatever values it take on the right quadrant, it takes the similar values on the left quadrants, right? Exactly same values on the left quadrant. So it's a mirror image around y-axis. That's why. Okay, so these are 5 identities, but there are more. So another one is, so what kind of function is tan theta? Now tan theta is again an odd function. Tan minus theta would be equal to minus tan theta. Okay, now there are these identities, sine theta plus phi. So let's say there are two angles, theta and phi. Sine theta plus phi would be equal to sine theta cos phi minus, sorry, not minus, plus cos theta sin phi. Okay, so sine theta plus phi would be equal to sine theta cos phi plus cos theta sin phi. Okay, then eighth, cos theta plus phi would be equal to cos theta cos phi minus sin theta sin phi. Okay, and there is a similar one for tangent as well, right? Tan theta plus phi equals to tan theta plus tan phi divided by 1 minus tan theta tan phi. Okay. So these are some important trigonometric identities, right? These ones you will use very frequently to solve numerical problems on trigonometric identities and trigonometric functions. Okay. So let us try to prove some other identities using these existing identities. Okay. So let us do some in-class exercises and try to prove some other identities. Can you prove this identity? Sine theta minus phi equals to sine theta cos phi minus cos theta sin phi. Okay, this is a simple one. So let us give it a try. So the function is the left hand side is sine theta minus phi. Okay, so sine theta minus phi can actually be written as sine theta plus minus phi. So think of minus phi as one of the angles, right? Now this is in the form of sine theta plus phi. Okay. So what would be sine theta plus phi? Well, it should be sine theta into cos of other angle minus phi plus cos theta into sine of other angle minus phi. Okay. But here cos of minus phi would be same as cos phi because this is an even function. So this would become cos phi. But here sine minus theta phi would become minus sine phi. So that's why here we get cos theta into sine phi. Okay. So that's proved. Similarly, can you figure out what would be cos theta minus phi? Well, let us see. Now this can be written as cos theta plus minus phi, okay, which can be rewritten as given our identity about cos theta plus phi, we can write it as cos theta into cos phi, cos minus phi, minus sine theta into sine minus phi. Okay. Now cos theta, cos minus phi would be just cos phi, right? So cos theta into cos phi. Now sine minus phi is minus sine phi. So that's why here it would be sine theta into sine phi. So that gives us cos theta minus phi. Okay. Let us try something interesting. Okay. So there is an identity that you need to prove. The identity is sine 2 theta equals to 2 tan theta divided by 1 plus tan square theta. This is another important identity, but let us try to prove this using what identities we already know. Okay. Now let us take the left hand side, which is sine 2 theta. Now sine 2 theta can be rewritten as sine theta plus theta. Okay. Sounds fine. Now what would be sine theta plus theta? Now this is sine theta plus phi, that kind of situation. So we can write it as sine theta into cos theta plus cos theta into sine theta. Right. Now this is actually we are multiplying sine theta cos theta two times here and here. So this becomes 2 sine theta cos theta. Okay. Everything is good so far. Now what if I divide 2 sine theta cos theta by 1? So it would remain exactly same. Nothing changes. So in denominator there is 1. Okay. But can I rewrite 1 as sine square theta plus cos square theta? Why I am doing this? Because I see here in denominator there is a term which is tan square theta. The only way I can get tan square theta is if I divide sin square theta by cos square theta. So, I need to use some terms involving sin square theta and cos square theta, otherwise I will not get this form. Okay. So, that is why in the denominator I replaced 1 by sin square theta plus cos square theta. Now, in order to get tan square theta, you need to divide by cos square theta. So, what if I divide by cos square theta both numerator as well as denominator? So, I divide 2 sin theta cos theta numerator by cos square theta as well as denominator by cos square theta, and let us see what happens. So, in the numerator, now one of the cos theta will cancel out and you will be left with 2 sin theta divided by cos theta, and in the denominator, when you divide by cos square theta, you will get something like sin square theta by cos square theta plus 1, because this cos square theta will cancel out. So, this gives us, because this is sin theta by cos theta, 2 tan theta divided by tan square theta plus 1, hence proved. This is exactly what we wanted here, 2 tan theta divided by 1 plus tan square theta. Okay. So, we have proved this identity. This is how you can prove trigonometric identities, new trigonometric identities, using existing identities that you have learned. Okay. All right, I will stop here. In the next lecture, we will practice some more trigonometric identities and how to prove them. Okay, I'll stop here. Thank you.